Yes, Basmi, am I audible to you?
Yes, ma'am.
All right. See, we started with this magnetic waves, and we didn't discuss this further. Let's complete this chapter. It's a very short chapter, and I'll just share a table with you where you will have to remember things again in this chapter, and one is there in chapter fifth. Okay. So electromagnetic waves are what? See, what are these exactly waves? Initially, I just talked to you that time varying electric field give rise to magnetic field, and time varying magnetic field will give rise to electric field. That's all what we started. Now, see, when we plot the equation of electromagnetic waves, when we actually write the electromagnetic waves, if I if I draw all the axes here, now see there are a few things which you have to remember here. Let's say electric field will also be acting here, magnetic field will be acting, and the wave will be moving in one direction. Three things will be there. Okay, what are these three things? One is the electric field. I told you, no, time varying electric field means electric
Yes,
field will be
ma'am.
varied. Time varying means the way we draw it in alternating current. Then
Hmm.
magnetic field, electric field, magnetic field, and these two are there. But you will also have to see where is the wave propagating. Electromagnetic wave is a wave. So where is it
Hmm.
propagating? Where is it moving towards? So that the third point is the direction point. So these three things are there. And all these three things are perpendicular to each other. That is one of the main properties of electromagnetic waves, that electric field, magnetic field, direction of propagation, all these will be directly proportional to each other. They're not proportional, perpendicular. Okay. So electric field, if
Okay,
this is
ma'am.
on, see, they can be on any of the axes present. It can be either on x-axis, y-axis, or z-axis, whatever. There is no constriction of an axis that this has to be on a particular axis. But if this is, let's say, on x-axis, this occurs on the y-axis, this will occur on the z. Let's change it. Let's say electric field is occurring on the y-axis, this on the z, so this will occur on the x. This is not a
Hmm.
possibility that electric field is on the y, magnetic field is also on the y, and this is along x. No, they all the three have to be perpendicular to each other, and they can be along any axis. But the only thing that you need to remember is all the three will be perpendicular to themselves, like the three axes, x, y, and z axis. Whenever you choose them, whenever you have any condition, all the three axes are always perpendicular to each other. Is there even a single condition where we say y axis is
Yes,
parallel
ma'am.
to x axis? We never say that.
No.
So similarly, electric
Yes,
field,
ma'am.
magnetic, the direction of propagation there. So if I just plot this, see, let's say this is our y-axis. This one, the dotted one, this is the z-axis, and this one is our x-axis. So electric field, I am taking that electric field is, let's say I have taken electric field like this along this xy, okay? Means x-axis. On the x-axis, the electric field is present. So electric field will be like this, a time varying. So this is what we studied in alternating current. You will not get a straight line or something. Okay,
Hmm.
just a second. Yeah. So the way in alternating current we studied that the time varying, whenever you have anything variable with time, we cannot draw a straight line. We cannot draw
Hmm.
hyperbola, parabolic, or any other sort of graph. This is how it varies with time. Okay.
Yes,
So
ma'am.
this is how it will be continued. Now it's like all the particles are getting displaced to these points. All of the particles of electric field, they are getting displaced differently with different time. If you see here, look, this is getting displaced with different time. All of the particles that were resting now are in different directions at different height. So like this, and this will be continued. I've just taken a small portion. The rest of the concept you can imagine that this will be extending wherever, because it's a wave. Okay, so this I have plotted along the
Okay, ma'am.
x-axis. All right. Now, or this is not actually along the x-axis. The direction, if you see here, this is acting along the y-axis. If I mark a point here, let's say this is our electric field. So electric field is acting along y-axis. Look, the coordinates are actually pointing towards the y-axis, not x-axis. Okay. So electric field, let's say this is acting on the y-axis. Whatever is it, whatever is its highest value, this is the y-axis, the negative one, the positive one, and this is the electric field acting there. Okay.
Okay, ma'am.
Let's take the magnetic field now. So let's say magnetic field is acting on the z-axis. Okay. Now a wave is moving. We are just taking its direction. You cannot take another wave here to mark it. I'll have to show it here only. So I'll just
Yes,
draw
ma'am.
it like this so that you get it like this. Okay. This is actually pointing towards the z-axis. The coordinates are pointing towards the z-axis. Like this, you can understand it. This is how it will move. Each and every particle of the wave is getting displaced along the z-axis this time. Here it was getting displaced along the y-axis. Here this is getting displaced along the z-axis. You can see the coordinates. The coordinates are
Yes,
directly
ma'am.
pointing towards it. Like this. You can see here, this is pointing towards, and this is the magnetic field. Now, y-axis is occupied, perpendicular to it, z-axis is already occupied. We'll say the direction of propagation will be along x-axis. Means the particles of electric field will move up, the particles of magnetic field will move outwards, while the wave itself will be moving towards the x-axis. So this will be the direction of propagation. This is where the magnetic field will be moving along the x-axis.
Mm.
This one is representing the direction of propagation of the wave. While this pink part, this one, is representing the electric field. Electric fields component, it is an electromagnetic wave. We discussed in the last class that electric field is also there, magnetic field component is also there. So the electric field component is this, and the magnetic field component is this. This is the magnetic field. Got this point? This much is clear to you?
Yes, ma'am.
Okay.
Yes,
So
ma'am.
these will be there and these will be perpendicular, and the rest of the writing part. So the equation is very important. The equation that we write, okay, everything that we'll relate will be with respect to this equation. So equation, I'll tell you once here, same equation will be used. Okay. Equation
Okay,
we'll do
ma'am.
for magnetic field also. So see, I am writing for electric field. The same equation is for magnetic field. Okay. So electric
Okay,
field
ma'am.
is E naught. Now E naught is what? In AC, when we discussed alternating current chapter, that time we had I naught and E naught. What
Yes.
what did that naught symbol in the subscript denote?
In the pure form. It was E by root 2, right?
What?
E was equal to E by root 2.
That is the formula of RMS.
Oh, yeah. Yeah, I was.
RMS is equal to E naught by root 2. IRMS is equal to
Yeah,
I
I
naught by root.
confused it.
Now tell me one thing. What is this? What is this? What are these? I'm asking these.
Pure in the air, in the
It
air
is
form. In the air, like
in
in
air.
its pure form.
This is
You
not
know, in
mu
its,
naught or epsilon naught. No, these were in air. What were these? Now you have to tell. What were these? This is not electric field. This is not the current in air and EMF in air. That was your mu naught,
in,
E naught, F naught, B naught that we wrote. That was for air. This isn't for air. This formula you remember. This formula also you
Yes.
remember. What was this? We did a whole derivation for this. How we got the value?
I sign. There was a sign, right?
Check your notes now, Basmi. You don't remember this. Check your notes. Now tell me, after looking in the notes, what was it?
Yes, ma'am.
Ma'am, an initial value, I guess. The initial current.
Yes, what was it?
Ma'am, is it the initial current?
Initial? We did a derivation for I naught and EMF, E naught.
Yeah, yes, ma'am. I is equal to I naught sine omega t.
Yes, but no, we did for E naught specially. We calculate the value of E naught for a full cycle, for a half cycle. What was E naught? What you haven't started with AC. This completely tells me. At least look
No.
into your notes. I'm asking you, look into your notes and tell me then. If you don't remember, just look into the notes. We did derivation for full cycle over a half cycle.
Yes, ma'am. E naught sine omega t plus
I'm not asking
pi.
the equation or anything. I'm saying what is that?
Oh, oh yeah. Okay, wait one sec. Peak value of EMF. Peak value.
Finally, why were you not able to tell this? The variables, if you don't remember, then when you'll sit to self-study, you'll not be able to understand anything. You were able to tell I naught sine omega t and all. You remembered the formula of RMS. You couldn't tell that that was the peak value. There's a whole derivation we did for the peak value over a half cycle and a full cycle, where one was 0, other came out to be 2 I naught by pi. We did discuss that
Yes,
average
ma'am.
value in terms of the peak value.
Yes, ma'am.
So peak value, that was the peak value of current, peak value of EMF. This is the peak value of electric field. E naught is here
Okay,
also
ma'am.
the peak value. Peak value means all these particles are getting displaced to different heights. This is getting
Mm,
displaced to a lesser height, then a greater height, then a greater height, like this. So the maximum displacement that the particle can achieve, let's say this is the highest displacement that is possible. This maximum value will become E naught. That's the displacement amplitude. We have lots of term for it. Amplitude, peak value. So this is E naught sine kx plus minus omega t. This is the whole equation for it. You don't have to derive this equation or anything, but at least remember the terms. If you don't remember the variables, there's no point. Did you
yes,
start
ma'am.
revising AC or you are still on EMI?
I am almost done with EMI. I still have to start AC.
Okay, no problem. EMI is done.
Almost, ma'am. I'm in the last topic.
At least
The
complete that. Then start with AC because see, after this chapter, the first book will be done, and ray optics is a complete different chapter. Okay. Then when you go
ma'am.
through AC now, I hope you will be able to remember then after this whole searching and all, E naught and I naught and RMS value and everything. Okay. So don't forget the variables at least. Variables, if you don't remember, at the end, what will happen? You will remember the formula and you will not know. That's why after every formula, I write what is the meaning of each term. Okay. So complete EMI, that's okay. Complete EMI chapter properly. But whatever you're studying should be done well. Then come to AC. Okay. E is the electric field over here. Now see, pay attention here. With me, pay attention here. Okay. This is important because this will be very, very similar to the chapter you have done waves in class 11th. Remember, there was a chapter, similar equation must be there. Sine kx omega t, interference, and all these things were there, if you remember. So E is the electric field. Electric field is the complete electric field, time varying electric field. Okay. Now see this E naught. What is this E naught? Now you'll be able to remember peak value. You remember the peak value of AC. So what was it? Peak value tells you the term. Peak means highest. The term peak means highest. We use this term. So peak value means the highest value. Yes. So this is
Yes,
also
ma'am.
the peak value of electric field, which is called as the amplitude. See, in class 11th, amplitude term was there. When a wave is there, all the particles of the waves are present. Let's say this is the part, these are the particles. If this rises to this height, 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 like this. Maximum displacement from the mean position is known as the amplitude. This was there in class 11th wave. Okay. So amplitude means the mean, the highest value, the largest displacement from the mean position. See, for the waves, just treat waves like very, very small dots that are resting on the axis. And when they are in movement, they are rising to different heights. Amplitude will be maximum displacement from the mean position. Okay.
Ma'am.
The highest that is possible. Okay, that's the highest value. Now sine, you already know this is the function of sine function. Angle part, this is nothing new for you, trigonometric value. Now what is this k? K is, see, it's a constant which we call as the angular wave number, and k is equal to 2 pi divided by lambda. What is lambda? Lambda is basically this lambda, this is known as the wavelength. Wavelength means when one wave is moving. So see, let's say it is repeating itself from this point. So this becomes the complete wavelength, the length of a wave, lambda. Okay. So this is what is lambda. So 2 pi by lambda is the formula of this k, which is angular wave number. This is known as angular wave number, this k. Okay. So k will be 2 pi by lambda. This is an important formula because most of the times you will be given the wavelength also. Or sometimes this equation will be given and wavelength is asked. So different things can be there. Now this quantity basically tells you the axis. If I write ky, that means electric field is along the y-axis. If I'm writing, this is just a general equation I've written. Don't relate it with this graph. Those were separate.
Okay.
This will represent the axis, whichever axis the wave is propagating. X-axis, so X. By looking at this equation, you will be able to get a complete information about your entire wave. Okay. So here X is the axis. Now the plus minus sign also hold a significant concept. Axes are also of two types: positive axis, negative axis. Like if I say this is the x-axis, so plus I cap minus I cap we write. Now the problem with this that this is reversed in the sense if I write plus here, plus minus means either of them will be there. So if I say plus, it means this is the negative axis. Okay, and if it is minus, that means it's the positive. So if it is plus, so don't think positive x-axis. If it is plus, it means negative x-axis. Okay, so that will tell you the exact location of the axis. Where is this electric field's maximum value to which it is rising? Which curve is it? Sine curve, cos curve. I told you cos curve starts from this. Cos curve is this. You already must be knowing from maths, and sine curve is this. So it's sine curve, cos curve. What kind of curve is this? Then wavelength, everything can be just calculated from this one single equation. Okay. And see, this omega is basically the angular frequency that is equal to 2 pi into nu. Nu is the linear frequency. This is the angular frequency, while this is the mu is the linear frequency. In fact, I'll write its formula also so that everything you have and you don't mess up with any of the questions, because these kinds of questions come often in the exam. So this is linear frequency, and this is equal to 1 by time period. Okay, so till this step you should know, till this step, because I have seen lots of questions coming from this. This is a very important topic. That's why I even started with this. I didn't start with displacement current. In your NCRT, this starts with displacement current, but this is so important that you give it a lot of time. You need to practice, but I'll tell you, it's not difficult. It's very easy. Lots of things are there, but questions are very easy. I'll show you one of the questions also that came in the board. It's like that this equation will be given, omega will be mentioned, linear frequency will be asked, like these. So you will be able to manage that, but yes, you have to remember the variables first for that. Yes?
Sure.
Okay. And T is the time. This just tells the time. Okay. Similar equation will be for the magnetic field that I'm not writing. Now you know everything from here. It's just that instead of electric field, this will be the magnetic field. This will be the amplitude of the magnetic field, and rest of the things will be the same. And one more thing, it can be written as omega t plus minus kx also. So if you see that somewhere, don't be confused. Why is that written? Okay. Now combining what is this electromagnetic wave before we move on to the spectrum part. Spectrum part we'll just discuss, because that you have to go through NCRT also. Two things just go to NCRT from your first book. Rest of the things, everything you have done it in the class itself. Even extra things you have done. So you don't even need to read NCRT. But for two things, refer to NCRT that I'm telling you very clearly. Though I'll share this table also with you. The magnetism materials table, that those part look into the NCRT because questions come from there. And second is this electromagnetic spectrum, because it will be like which wave is used for cancer treatment, like this. These questions are there in the exam and questions come. So see, this says an electromagnetic wave is a wave radiated by accelerated charges are in acceleration, and which propagates through space as coupled electric field and magnetic field. Both of them are there. Oscillating perpendicular to each other as well as perpendicular to the direction of propagation. Okay? So tell me, everything is clear till here?
Yes, ma'am.
Oh. For the spectrum, we'll do the properties. This was already written, na?
Yes, ma'am.
Please continue it from here.
Okay. Ma'am, can you scroll down? Ma'am, can you scroll down? Ma'am, I'm done.
Okay. See, electromagnetic spectrum I'll discuss later. First, let me come to the properties because this is in continuation of this. Otherwise, you'll not be able to understand. Okay. First property, as I discussed with you, that all the three of them will be perpendicular to each other. Electric field, magnetic field, and direction of propagation, they are perpendicular to each other. Second point is that, see, electric field, if I use the relation that we have already done, QVB is equal to, this is the magnetic force is equal to the electric force, if I equate them. So charge will be cancelled. Now electromagnetic waves travel with the speed of light. So from here, I can say the speed of light will be equal to electric field divided by the magnetic field. Yes. Or if I take
Yes,
a
ma'am.
random value also, velocity will be equal to, the velocity will be equal to electric field divided by the magnetic field. But usually the speed that we take is the speed of light. And if we take the peak value, then this will be E naught, this will be B naught. This is often used in the numericals. This one and this is very important. What's the speed of light?
I don't know.
You don't remember the speed of light? I have told you.
You said I
When we
don't
discussed
remember the
electric
last
field, I told you electric field travels with the speed of light because of electromagnetic wave. 3 into 10 to the power 8 meter per second.
time.
Okay. Next, speed of EM wave in vacuum. See, T is equal to 1 by under root epsilon naught mu naught. This is from the electric field and magnetic field only. Okay, this is the formula of the speed of EM wave in vacuum is given by this formula. C is equal to 1 by, see, if I put everything in this formula, no. Okay, while value of epsilon naught, at least you can tell me.
0.25 into
8
10
point
to the power minus 25. So 85.
into,
Yeah, 85. Into 10 to the power minus 19.
no. Just tell me, how did you attempt that revision test? Did you do that honestly?
Yes, ma'am. I keep forgetting this value.
Whichever values you're forgetting, just jot them down on the paper so that
Yes, ma'am. I'll
yes,
have it
because
written down
epsilon
here.
naught and all, speed of light, epsilon naught, these are not even given in the question. So these you have to remember by yourself. Okay. So it's okay. You can get confused and you can forget the values. You are actually relating it with the electronic charge. But forgetting is okay, but not working on that is not correct. Okay. So you just work on that. Whatever things you're forgetting, keep on revising them. See, chapters are a lot. You cannot do anything. You have to manage with the syllabus. Once the 12th is done, you will have to revise your 11th part again for JE. Yes.
Yes,
So
ma'am.
lots of things will be there. Value of epsilon naught, mu naught. No, this way you'll not be able to. Why are we having the classes so soon then? What is the rush of the syllabus then if you're not revising? I think I'm asking you very easy questions. I'm asking nothing from this. Recall. Okay, now recall. Remember your man. Take time. Recall it right now. Mu naught we write. Biot-Savart law. Remember that. Try to remember that.
10 to the power minus 7. That's not right.
What?
Is it, ma'am, is it 4 pi into 10 to the power minus 7, I think?
No,
Is
tell me
this
one
correct?
value.
Ma'am, mu naught, is it 4 pi into 10 to the power minus 7?
Yeah, so be confident for that. You are still not confident
Yeah.
about it. It is right. 4 pi into 10 to the power minus 7. Now don't forget these two things. Okay.
Yes, ma'am.
Pi we know it's 3.14 and this is 10 to the power minus 7. So you were right. See, when you solve all these things, when you will solve this, use calculator or anything, you will get 3 into 10 to the power 8 meter per second. So 1, 2, and 3 should be remembered. Okay, because these are properties written in your book in the NCRT. So you are expected to remember them. Okay? Clear till
ma'am.
here?
Mm.
Okay. Now see, if it's in a different medium, like if I talk about the EM wave in a different medium, so that time we'll have some random speed which will be equal to 1 by under root mu into epsilon. Mu and epsilon are for different materials. These are for different other medium. Okay, and this will be some new speed. Okay, so what we have, there was a relation, if you can recall, relative permittivity and relative permeability. Remember?
Yes,
This we did,
ma'am.
I think, recently also. Mu r we did in the last chapter. So see, if I replace them, the speed in a medium, this is a speed in a medium, okay? Not air. We are not taking
Ma'am.
air, we are just taking a medium. So if I write this, this will be 1 divided by mu can be written as mu naught mu r. Epsilon can be written as epsilon naught epsilon r. It is. Now, if I just separate the terms, if I just separate it like this, 1 by mu naught into epsilon naught into 1 by mu r epsilon r. The same thing.
Yes, ma'am.
Now, what did we just study? This term was,
VM.
it was
No. Ma'am, the code is C.
C.
Yeah, C.
Yes, this. It's
Yeah,
not a mind class,
C.
Basmi, you can speak. C, yes. Okay, speed of light. This is the speed of light, okay? Speed of light in air. Okay, the value 3 into 10 to the power 8 meter per second is exclusively for air because see, we took mu naught, epsilon naught, the ones that you were answering for the peak values. Now comes your medium air. So see, speed of electromagnetic wave in a medium can be given by C divided by under root of mu r into epsilon r, where these are the relative terms. Okay, epsilon r is what? Relative permittivity. This is relative permittivity. And mu r is the relative permeability. Got it?
Yes, ma'am.
Okay, rest of it I'll tell you later. First, you write down these 4 points, okay? Because numericals come from the second one and this third and fourth one. Numericals come from this, okay? Write down the properties.
Ma'am, can you scroll down? Ma'am, can you scroll down? Ma'am, can you scroll down?
Done here?
Yes, ma'am.
Okay. See, regarding the refractive index is basically, see, there's a formula, refractive index. Do you remember from your earlier classes? Class 9, no, class 10th was there where you had this refractive index concept. Have you heard of the refractive index?
The refraction, yeah, not refractive index.
Okay, refraction, you remember? Refraction term you
Yes,
must have.
ma'am.
Okay. But don't worry, this we'll be doing in detail. Refractive index is there. Refractive index, I'll just tell you very briefly because we have to do it again. Refractive index for mirrors, lens, all these materials, the optical density, not the, see, one you have the material density. The optical density is given by the refractive index. It's like a measurement, okay? So basically the speed of light is equal to, sorry, the speed in a medium is equal to speed of light divided by n. This whole term can be written as the refractive index. So since this is one of the properties in Basmi, if it comes in the final exam, you'll have to mention the optics part also. So write it in your notes. The understanding of refractive index and ray optics will be done in per itself. So, but if you have it in the notes when you write, you have to mention it, okay? And yes, all optical phenomena that occur, these two are basically from your ray optics chapter only. So all the optical phenomena means all these things related to the ray optics and all. These phenomena that occur are due to the electric field only. There is no role of magnetic. Whatever optical part is occurring, the optics related, like refractive index, because see, when we'll see if a lens is present and a ray of light is coming and it is getting deviated, bent, refraction is occurring and all. So all these travel with the speed of light, and sometimes these are electromagnetic waves also that occur. Okay, so that's why we are required to study about these 2 points. Okay. One is energy density. Energy density, we have already done this term in potential chapter, if you remember. There was this symbol for energy per unit volume. Now its formula, can you tell me? Electrical energy part is already done.
Electrical energy.
Before, I'll even tell you where we did. Before we did the force between two parallel plates in a capacitor.
That was third chapter, right? Third or fourth chapter. And energy was
Have you read this somewhere? Have we done this?
yes, ma'am.
Electric field was sigma by epsilon naught because of two plates. Then sigma was written as Q by A epsilon naught.
But
Yes, we did something like this.
yes, ma'am, we did.
Yes, so that derivation can come in the exam. I told you that time that it will come again in EM wave. So remember that properly. The whole time I've been telling you which term will come again. So this is the electrical density, and we did the magnetic energy. See, magnetic energy is half. E square is there, so this will become B square. It is getting multiplied to epsilon naught. This gets divided to mu naught. So this is the magnetic density. And this is the electrical energy. Electrical and magnetic, these are the densities. So if we combine them, if I add both of them, this will be half epsilon naught E square plus half B square divided by mu naught. Okay, when we add them. Now see, these values that we talk, these E and B, these are actually the electric field's RMS, because this is also sine curve. The way we studied in alternating current, for current we studied. So similarly, you can relate it with ERMS. This is the ERMS value, while this is the magnetic field's RMS value. Like the RMS value, okay, root mean square speed when it is taken. Because these are also following the same sine curves. Now comes your favorite formula, which you remember the whole time. E naught by root 2 and B naught by root 2. Here also it will be used. Okay, like we had I naught by root 2 and E naught by root 2. Those E's are different. This is electric field. That was EMF. Yeah? Okay.
Yes, ma'am.
So we know if we square this, it will be ERMS square will be E naught square by 2. BRMS square will be B naught square by 2. This is ERMS only. Okay, ERMS and BRMS. So if we write the squares value, this will be half into epsilon naught into ERMS square will be E naught square by 2 plus this will be half into B naught square by 2 into 1 by mu naught. Yes, half epsilon
Yes.
naught RMS square, half BRMS square by mu naught. So this makes it 1 by 4 epsilon naught. Peak values formula will be this. Now, one thing I'll tell you, numericals I've seen very less from this. In your board exams, numericals are very less from this. Usually it comes to prove or find the total, derive the total energy density. So this is the total energy density, okay? If I take this is the total energy density. This part will be the energy density due to electrical, and this will be due to the magnetic, and that too including the peak values. Without the peak values, it would be like this. All right.
So, ma'am.
Okay, momentum and intensity would be left, no? You write down till here first.
Okay, ma'am. Ma'am, should we scroll down? Ma'am, can you 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 scroll down?
It's done.
Yes, ma'am.
Okay. Momentum, when we calculate the momentum of electromagnetic waves, okay. See, electromagnetic waves transport a linear momentum as they travel through the space, okay. So the linear momentum, what's the formula for linear momentum? Do you remember? Class 11th, momentum, mass into velocity, okay. MV, momentum is mass into velocity. So electromagnetic waves, I'll write it, EM waves deliver a linear momentum, whose formula is given by this. Again, I'll tell you, the questions are rarely asked from this alone. Okay, whatever questions come, they come in combination with your the properties. Okay, combined properties when it comes. So for the complete properties, you need to remember that if the properties part come, then this ninth point you'll have to mention as momentum.
Yes,
Write
ma'am.
just one line, write the formula that this is energy density divided by the speed of light. I just mentioned P is the momentum, this is the energy density, and C is the speed of life, speed of light. Okay, now what is its value?
3 into 10 raised to 8.
Yes, 3 into 10 to the power 8. Very good. When you come for Saturday's class, because tomorrow is an off, here we have your school is also off, no? This whole week too?
Yes, ma'am.
25th Monday
Yes,
it will
ma'am.
start. So this is the last week.
Yes.
Okay.
Mm.
Vacations are also about to end then. After a very,
Yes,
very
ma'am.
long time, no? Okay. The speed of light and okay, just one thing. Yeah, once a question came, I'll just tell you one thing here. See, when this electromagnetic wave strikes on a material, let's say this is the initial momentum. So we will take the downwards direction as some positive. Let's say downwards is positive. Okay. So what we are choosing? We are choosing down as positive. So for an absorbing surface, this will occur. On an absorbing surface, the momentum ray has strike, and this is the momentum. When it gets reflect, if it's a very smooth surface, then see, according to the sign convention, then up will be negative. So the momentum that goes away, it will be P. Now see, when I calculate the change in momentum, now this is a little related to your class 11th. If I calculate the change in momentum, this will be final minus initial, final T. This is the final P2 minus P1, which will be minus P equal to minus 2P. Okay. Force is rate of change of linear momentum. That was the Newton's second law. Okay, F is equal to ma is,
Yes, ma'am.
formula was rate of change of momentum. So rate of change of momentum is this. Once a tricky question was asked, and this hasn't been asked again, but you should know when it comes. Now, what happens to the momentum here? So you'll have to remember momentum will be double, because it is not getting cancelled.
Okay, ma'am.
Positive, this is negative. When you subtract them, when you basically, it will be, when you are subtracting, it will eventually be added. Even if you take the opposite direction, let's say if we take down as negative, up as positive. So P2 becomes plus P, P1 becomes minus P. Now see, P2 minus P1. P2 minus P1 will be, this is P minus of P. That again becomes 2P. So remember, it will be twice. So force become twice the
Okay,
momentum by time. This is an important conclusion which you should. Okay.
Okay, ma'am.
One more property is intensity. Intensity is basically energy per unit area per unit time. All right. And if I tell you, can you just tell me what is this?
Energy by time. Heat? Is it heat?
Is it
Heat?
T?
Heat.
What is T?
No, ma'am. Is it heat?
C, speed of light.
Heat. So, no, ma'am. Is it heat energy?
What is it?
Ma'am, is it heat energy?
Voice isn't coming, Basmi. Are you speaking something? Say.
Ma'am, is it heat energy? Oh, no, it's energy by time is it power? I think it's power.
Now your voice also came correct and your answer was also good. What were you saying before? Now your voice is fine. Yes, say.
Ma'am, I thought it was heat, and then I realized it's power.
Okay. Yes. Yes, because your initial answer was your, I think, voice cracked in between. That's why your voice wasn't coming, because
Mm.
it was fine. Yes, now it's fine. Yes, it is power. You are right. Energy per unit time is power. You initially thought that this is the speed.
No, ma'am, heat. HEAT, heat. Heat
Okay,
energy.
heat. You thought it
Yeah,
was all right.
yeah.
See, heat will be equal to energy. Okay, you were closer. That was okay. Heat heat is the heat energy only. The actual full term is heat energy. So when you have power, you can say heat by time itself. Heat will be doing exact function of energy, and same thing, energy, heat, and work done. These three are the same. Okay, but yes, very good.
Okay, ma'am.
Identified this as power. If power is given, so your intensity will become power upon area. Okay,
Okay, ma'am.
let's see. If I write the SI unit from here, this is joules per meter square per second, or from here you can simply say watt per meter square. Got it? There's one more point of
Yes,
it.
ma'am.
Not one more point. Two more points are there. Intensity done, momentum done, energy density done. Ray optics both done. Speeds done. And the proper two more points are there. One is that, see, these EM waves are not deflected by the electric or magnetic field. I'll just complete this. EM waves are neither deflected by electric field nor by magnetic fields. Okay.
Okay, ma'am.
And one more last property for this is that EM waves obey the principle of superposition. Superposition. We have a chapter wave optics. After wave optics, that time we'll understand this principle of superposition means for waves. These electromagnetic waves are waves. Like we've already studied superposition for electric forces, electric field and all. So here also superposition comes and you have refraction, reflection and other concepts there. Interference is there, diffraction is there. So these four concepts are there: refraction, reflection, diffraction, and interference. Just have this for the notes part because you have to do everything in detail. Because when you complete those portions and when you revise this, then you should be able to have this completes the whole properties that are present in your textbook. Okay.
Okay, ma'am.
Uh, Tell me one thing before you write. Have you understood everything properly in today's class?
Yes, ma'am.
Okay. Just do one thing. See, you prepare whatever you're studying, whichever chapter you're doing, you complete that. But before coming to the class, tomorrow is and also Saturday morning, we'll have the class. Morning only, let's have it because Saturday I'm available in the morning. So let's
Okay,
have
ma'am.
Sunday also we can have if you want. Sunday, Saturday, Sunday,
Ma'am.
Monday. These 3 days till Monday I can take your class regularly. Tuesday I can't take. Tuesday I'll not be able to take, and Tuesday I'll text you whether the complete week when I can take the class or not, because probably by after
Okay,
Tuesday
ma'am.
I'll not be able to take your classes. So at least let's have the classes consecutively till Monday. But I was just saying, before you come to the class, just go through the notes honestly. Okay,
Okay,
at
ma'am.
least the notes part. Okay, please write it.
Ma'am, can you scroll down? 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 Ma'am, I'm done.
Okay, all right. So, Basmi, I'll stop here. Saturday we'll have our class. Just go through the notes. That's
Okay,
enough.
ma'am.
Go through the notes. And
Okay, ma'am.
from EMI, do you have doubts in the assignments? Just tell me so that I can discuss it in the next class.
Uh,
I think one assignment is still
I'll
left.
check and I'll send you.
Are there any assignments left from EMI chapter?
No, ma'am. AC
On the
chapter there is two, but not from UMI.
Okay, then I'll check myself whatever questions you have not attempted, because I just remembered now, right now, that I think one or two questions were there which you didn't attempt. Means they weren't wrong, but you haven't attempted them. So let's complete all the assignments, because few assignments were there, few questions were there. So I'll discuss that on Saturday morning first, okay? And then we'll complete this
Wow.
chapter. This chapter will be done by Saturday itself. I'll try to complete this, okay? And just tell me,
Okay,
Basmi,
ma'am.
what do you want? Like once this chapter is